Okay, so I guess we're live now. So yeah, hello everyone. Welcome to the channel. Welcome to this webinar. On the behalf of Engineer Hub, I, Kumar Vidyanivas, would like to welcome you all in this webinar with this session. And we are back with another episode of this Weekend with the series. Yesterday we are having some network issues, but this time I make sure there is no any internet connectivity issues or there is no any lag. And guess what? This time we are having our DevOps engineer, Ayush Gupta, who is well expert in this field, well expertise in this field. So without any making single minute delay, we will move to our the theme of this session, that understanding of the Docker. So Ayush, all the stage is yours. Please, over to you. And yeah, all set good.
Hi everyone, मजा में and thank you Kuvar for very welcome, charming welcome. Yeah. So quickly moving towards my short PPT, after which I will be showing some sort of a, if possible, if there will be time, I will be sharing some sort of a glimpse on the VM as well, a practical session sort of, which you can say. Yep. Okay. So just tell me
Sorry,
if my screen is visible.
sorry, Ayush. Sorry to interrupt you. But before moving to the session, would you like to tell a little bit more about yourself to our audience?
Okay. So yeah. My experience in DevOps is right now like 3 years around. Yep, I have been working in this particular field for 3 years. Relevant experience here, and throughout my journey, the topic we are going to talk is one of the popular topic within the companies. You most of you will be hearing about like moving towards microservices.
Yeah,
Okay, so this is the basic first step that you should be moving towards the microservices. You should know what is containerization and all. So we will be getting interact with what is this, and we'll also learn during the session itself why there are certain older strategies doesn't able to work, and why why we have to move towards this dockerization and containerization of these things. So yeah, I am very excited right now. So we can quickly move towards the session.
yeah, sure.
Yeah, just
Please
give me a
proceed.
confirmation, Kumar. Yep, just give me the confirmation if my screen is visible. Yeah.
Yeah, it's
Yeah,
perfectly
my screen is
visible.
visible.
Yeah, it's perfectly visible.
Okay. So yeah, coming to this introduction to containerization. Okay. So there is this long story back, like software development used to happen in your virtualization tools and what do you say, very giant big parameters. Parameters I'm like referring to the original machines that you are having, this physical devices, the laptops, the computers. Okay. So on this we are used to have our deployment. We used to have all these you can say development sort of fields or everything. Okay. But over the time, what has happened right now, in somewhere near about 2006, 2007, we get to heard about this virtualization. Now, virtualization is something sort of, you can say, a virtual world. Okay, so where a physical device doesn't know like how many right now OSs can run on over it. Okay, we will get into the more detail of this. I'm just giving you a glimpse. So in virtualization, if you can think within a same physical device, if most of you are knowing about this, I think you should be knowing about like a single computer can handle most two OS. Okay, or 3 OS. But using virtualization, you can run 10 of OS at the same time. Okay. This was the powerful thing about the virtualization. But virtualization also lag at some point. We'll see what was these. And coming towards this later on phases, somewhere around 2008, 2010, somewhere around, we got to know about this new tool which came into the market. It was building in that stage. It was going to build, but later on phases it got build. That name also will know about the person who built this. The term came out from this was the Docker first. In terms of containerization, The containers were first heard by one person, and that particular containerization tool was named as Docker. Okay, and from there we have started this containerization tools. We will see what's the use cases, why we are using it, and it's a, you can say, छोटा पैकेट बड़ा धमाका है ये. Okay, so yeah, coming on to this, what will the keynotes for this? So we'll be listening about what is virtualization. Then we will be looking into what is containerization, what will the differences, what is the advantage, disadvantages of using containerization, and why people are shifting towards the containerization more, and microservices is what is microservices as well. Yeah. So yeah, coming to this, most have you heard about virtualization? Just now I'm always talking also. So virtualization is something sort of where you got efficiency and management of the hardware tools. Basically, what I mean about this, you're right now able to look on this particular picture. So if you heard about the AWS, about this, you can say Azure cloud, you can say like GCP cloud. There are other most, Alibaba and all. So what they do, they used to have these sort of devices in the data centers where they allow you to manage their devices on your own, and they allow their bare metals to be used as the virtual devices for you, and this some sort of a called as tenancy for you. Okay, so this is some sort of different part which we are not going to talk in this particular session. So yeah, coming to this particular virtualization, what is server virtualization? On an OS, we have some sort of a driver, which you say as hypervisor. Hypervisor gives you ability to share your. Okay, let me just brief you one thing about any running any OS. That is something like you can say to run a OS. You must know like the basic four elements that are required. That is, which is storage, CPU, RAM, and the network. Okay, so these are the four basic elements. And within a bare metal, if you see, you will always, if you don't have anything, rest, or I will say any graphic card, any sound card, any nothing you have, but still you can run the an OS based on these four. Okay, so running any OS, so someone got to have this particular mindset back then. I don't know right to the name, the person who built this virtualization technology, but this was the change in this, you can say, computerization field, which give a start to this cloud computing. Okay, now in server virtualization, what happens is a hypervisor is a sort of a driver. You know, whatever you use, maybe a printer, maybe a pen drive, each one of it requires a driver to be connected or to be understand by the computer, like this particular device is used for what. Okay, and what how I can interact with this particular device. Okay, so for this, a hypervisor, similarly to this, okay, similarly a hypervisor is also a driver which is used to interact from our physical resources of the devices over which an OS can be run. Okay, so this gave us a new path toward the virtualization field. Now what happens is hypervisor tells the OS that you have a virtual, or you can say a physical device only, but in actual terms, if I tell you, those are the bypart of this storage. Like let's say if you have the storage of this part, okay, so some part of it will be given to this OS, some part of it will be given to this OS. By this is all happening from the physical device. So parts of physical devices will be given to this particular device, these above devices. So what I mean by above devices is these are the machines, or you can say the users are going to use these machines. These are machines are the actual machines which are containing an OS or running an OS. Okay, so the simple example for this, let me just switch my screen again and just represent it. Okay. Okay. So let me just show you one thing more. What I meant by this. Right now I'm running Kali Linux. I can run Kali Linux. I can run Red Hat 3 OSs at the same time. And this is one of the Red Hat. CentOS is also there. CentOS I can also run. So this is one of the virtualization tool which I use, and we are going to use in this session as well for the practical part. Okay. So now coming back to this, so this particular virtual device what will it will do? It will use this particular hypervisor And till these each of machine, if you will see over there, each of them has their own RAM, own storage, own network card, and other audio devices if you wanted to connect. But as I said, four are the basic elements: storage, network, your RAM, and the basically the CPU part. Okay, the CPU is also there. CPU, if you will see in the in the processor side, so you have these processor. How many processors? If I have 8 core of CPU, then how much I can consume for this particular machine? So out of the 8, I can use 3. Okay, after which the system will make some sort of issues. So this is some sort of virtualization device which people use. Another tool is there, which we called it as VMware as well, which is also now in market used very well for virtualization. Okay. Now, what's the use of virtualization? Like, take an example. Someday you wanted to run a different OS. Let's say right now my machine is running as a Windows OS, and someday I wanted to run Red Hat. Another day I wanted to run somewhere. I have a use case in the company. I wanted to run, which can be run only on a particular machine. Let's say CentOS, or maybe on Ubuntu. Okay. So in that cases, you don't have to buy another laptop, or you don't have to switch your particular whole system bare metal. Okay, in that case, what you can use is the virtual machine for testing, right? So this was the case where virtualization was one of the use case, you can say. Okay, but this was a very well, you can say, one of the crazy move which was taken by the industry to use virtualization, or one of the biggest you can say invention in the history of computerization, the virtualization, which help us this using cloud computing as well. Okay, now little bit when we move towards you can say farther from this virtualization. Now containerization, in a virtualization, what happens, let me just brief you a little bit more. If you can see my particular, everyone of you must be knowing, like for running any of the machine, any of the thing, we need to run a process, right? So even if I run a particular Brave browser, I am running a process. For running a terminal, I am running a process. Each of these processes will have their own IDs as well. We will see in my particular machine in the VM itself when we were running it. So similarly, for running a virtualization machine, the drawback was there was multiple processes that were going to run behind the scene, and there was also a limit running a particular at the same time. If I wanted to run 3 or 4 virtualization machines, heavy machines, I'm saying. Okay, let's say I was doing I'm using a 10 gig of RAM for running a particular OS. So I cannot, if in a 16 GB RAM OS, in a 16 GB RAM bare metal, or you can say machine, I cannot run more than 2 or more than 3 machines. Okay, then my system will start crashing, because my bare metal also requires some space to run, over which I'm using virtualization machines, 3 of it. So the bottleneck will be there for the RAM, for the CPU, for processing and processing the RAM, also for using this particular CPUs for further work, whichever I'm commanding or whichever I'm doing. So for that drawback, we find out something different where we said containerization. Now containers are something, you can say, using containerization tool. What is happening right now? A single OS can be run within 1 second, okay, or maybe 2 seconds or 3 seconds, within seconds, you can say. Second thing, what was the benefit was using containerization was a single process is going to run for each and every OS. So you can say a minimalistic form of a dependent things were kept into a package, which can be run in the form of an OS, and you can run it. So right now I'm also using one of it. So if I let you know, this is the Red Hat machine. Okay, if I tell you who am I, it's root. And if I check it over here, it says Gideon Martyr. If you say this could be a cloud machine as well, right? But I'm running it on my local OS. This IP, if you are able to hear, this is the local IP. Okay. So now this way I'm going to enter into a virtual machine. We also saw that This is the Red Hat machine that I'm running right now. Okay. So this is a complete new OS, completely itself a OS. Okay. So now if you will see what's the power of OS right now, if you will see inside my containerization tool, okay. So right now, if I am running a virtual machine, okay, how many processes are running? Too many. Okay. Now coming to this, if I run this new virtual machine, let's say on -IT CentOS, don't have one. No problem. Hmm. Let me just quickly install one. Let's see. Okay, no problem. We have another different. This is also one of the virtualization tool, Podman. Okay, similar to Docker. There are all the commands that we use in Docker. That's also similar. There's some sort of a issue with my Docker machine right now. We'll see in the next session if I can provide it. Okay, but meanwhile we can use this one. Okay, let me run this. Okay, let it pull the image and we'll see. Okay, now coming to this containerization. What is containerization? Containerization involves the building of an application with all its dependency. Let's say I just wanted to run a web server in my particular OS and I wanted to expose it to software. Okay, so from a particular machine, I will be running a single process with a small dependencies, whatever is required to run that particular server, and that particular OS will be able to expose as a server as well. We'll see how we can do it. Okay, now coming to how it works. So a single container image are similar to like OS images. So OS images are the two large images, 9 GB, 10 GB, maybe 2 GB as well. But the container image are mostly in the MBs or maybe in KBs most of the time. Okay, so you will be able to find it over Docker repository. Docker is one of the repository where all the images are kept publicly. Okay. Also, you can keep your private repositories. So it's you can say just like GitHub, we also have our private repository in this. And let me just show you quickly. I'm just giving you the glimpse of how Docker works, how Docker keeps your images. So these are my private images which I have kept in my environment. But there are another as well, CentOS. You will also find Windows 10 over there. Okay. So there are plenty of there. Okay. This is the one of the wins. You can say Windows machine, Windows scheduler. Based on the use cases, people keep their packages, and most of the you can say if you have heard about this Nginx, like one of the server used for exposing your machines. So Nginx is also one of the server, one of the machine which is used. Okay, so this can be used. Any user must have been using this. Okay, if you have typed the wrong name. So there is verified Nginx server. You can available image as well, which you can use for exposing our website. Okay. Now container registry we have talked. This is the only container registry I'm telling you about. So this is the Docker container registry. You can also create your private registries. ECR is also one there, which AWS gives us. And the container orchestration. Container orchestration is somewhere. Let's just skip this part for now. We'll see if I can cover this up. It's a second thing. Now benefit is three things are there: efficiency, scalability, and consistency. Consistency is what do you mean? What do you mean by consistency? Since the particular images or the particular machine is running in a single process, okay. So now you can run at the same time multiple processes, and you can also expose them. Okay. There's some sort of other thing you can use a load balancer over there. Load balancer is some different concept. I'm just telling you to drive the traffic from one consumer to these three machines or four machines, whatever you are having. You use load balancer. For that, consistency can be maintained a deployment environment. Okay. Scalability. Now let's say today my consumer demands increases. Okay. from 4 to 5. My 4 people consumes, let's say, one machine. Now 5 people have come. 5th people will require a third machine or second machine, sorry. So for that, I can easily restart, or I can easily provision or start a new process for scalability. Then there comes to the efficiency. Efficiency is the part where, since I am coming to this consistency and scalability, so efficiency is somewhere you can automatically think about, because it's lightweight. A single process, you know about how much RAM it will take, how much CPU it will take. I do hardly what 1%, 2%, or 3%. At most it will go to 10%, but that's the very upward case where you will see like 10% of the CPU is used from my particular parameter. Okay, so coming to this, what's the difference between virtualization and containerization? So if you can see this particular image, okay, so this is some sort of hardware layer which I am talking about again and again. The bare metal is your actual machine, okay, which you are using right now for having this meeting, over which we will be having this hypervisor, and hypervisor will allow you to run this particular Windows OS. Okay, this is something different concept where you can extend this virtualization to the next level. This second level of two levels of virtualization is there. This is possible with a particular machine. Okay, let's just talk about this one, and then we'll move to this containerization. Now containerization is something where you can say the infrastructure is there, over which you can have a host machine. See, containerization are two levels. Over virtualization you can also do the you can use the containerization. Also in your bare metal you can use the containerization. Both way you can do. Okay, so coming to this, now Docker and Kubernetes is something different. So the Kubernetes is some sort of a to manage containers, okay, or to manage Docker, you can say right now. Podman is also one of the there are other tools, Kra.io, and most of them are used for this containerization tools as only. So Kubernetes is some sort of a managing device or the powerhouse for controlling all these containers within a environment, you can say. So if you are building a new environment, exposing a new application, so you will be using this particular Docker for running your applications, small applications. But if you wanted to manage them and you wanted to control their deployments, you wanted to create the replicas or the duplicates of these images and transfer these traffic of your users to this Docker containers, then you will be using this Kubernetes. Okay. Now, what's the IT improve? What how containerization improves at IT operations? So automated deployment. Okay. Now someone doesn't needs to come again and again and create a script or sort of something. It's just a matter of time. You just need to hit a command and you will be able to run deployment or something sort of. And since the image size is too low and development time is too low, so deployment automatic deployments are also faster. Okay, so if someone is developing a new software or something, or he wanted to give a patch on this particular software, within few seconds a new deployment can be reached, or a new deployment can be reached to this particular server. Okay, now faster scaling is coming from somewhere. You can this is what we are talking right now, using load balancer. So for that we are using this particular scalar part, and scalar part is where you can be able to launch particular containers again and again. Okay, let's say one or two or three, whichever is required as per the requirement. Now coming to effective resource utilization. Okay, so this is one of the major point of containerization. Now let's say when you are running a VM. Okay, so I just told you there's a limitation of running a VM. Even if I am going to run a particular OS, I need to open a 2 GB OS in my virtualization machine, and then I have to expose this to the world. Okay, in that case, just think about, will you be able to manage two or three or four, more than four, let's say, in the same case that we are talking about in the back, the same scenario of 10 GB? No, I guess no, right? So for that case, containerization was brought, and lightweighted containers. What we mean, we just saw how much was the size of this particular image. Let's just see the particular image that we just pulled. We will see how much size was there. Okay. Podman. So yep, this was a particular image, and how much size it was? 239 MBs. And if you will see a particular CentOS image, the OS will itself be in GBs itself. Okay, so running that particular OS in a particular system, downloading is one of the first tasks. Okay, how much time took me to download this particular image? I think 2 minutes approximately, 2 minutes 31 seconds. Okay, now let's just run this particular image and let's just show you some crazy thing about this. Uh, you can say already we are running, I guess. Mm, yes. Yeah. Okay. It got exited. No problem. Let's just run this. I don't know. Let me just pull a different image. That particular image is getting some sort of an error. Let's just see. Fedora, if Fedora works. Fedora is also one of the, you can say, OS. Linux OS itself. Okay. And we'll see for this. Uh, Sorry guys for these pop-ups. Yeah. So containers are lightweight and require fewer resources than traditional VMs. Why I said I just saw you like how many processes are running behind the scene for running the virtual machine. But for running just now, we will see a single process will be handling over this particular Podman. Okay. If you will, let me just show you in a second or few seconds. Let me just bring that particular image up, and we'll see that. And considering when the implementation of consideration is, so it's typically implementation is required. So for the security part, for the portability and the integration, these are the 3 points. Security in terms of like you can say, uh, right now, if I running a particular environment in a particular, I wanted to run a database connector or an API that's my backend API, which is going to connect to a database. So for that, and I wanted to keep this particular database protected from my unauthorized actions. Okay, so for that, what I will be using, I'll be able to use this particular Podman or you can say Docker containers in my particular environment, and will be able to expose it via load balancer or something sort of like that in a private network. So whenever a public environment wanted to fetch some information, this particular container will be able to fetch the information from the DB. Okay. Scalability is there. That's why we are using this particular container. Now, let's say somehow this particular pod gets, you can say, captured by anyone, or maybe it got privilege escalate. In that case, you can immediately shut down but that particular OS or that particular container, and we can relaunch a new one. Okay, so this is some sort of a security wise, it's a better format, and this will also not impact our resource or downtime or something because within few seconds we'll be able to bring up a new container or Podman containers. Okay, portability is there. Now anyone has developed a new software, so within a MBs or GB, within you can say 1 GB, if you will see a particular image of Docker that will exceed at most 1 GB, not more than 1 GB. That's a very you can say very bad case, or you can say very bad use case in which more than 1 GB will go with a particular Docker image or a particular Podman image. Okay, but an OS image in containerization world will be approximately somewhere around 200 300 MBs. Okay, this is the very normal size of using a particular image, and we are also pushing using something different techniques. You can also push it towards downside. You can say push it in towards the KBs or MBs as well, 1 or 2 MB or 3 MB. This is also some of the use case. And coming to this integration, so yeah, containerization is some sort of a tool where you can VMs are not cannot be so easily integrated. But using containerization, you can integrate this particular thing into your environment or something wherever you're using or deploying the whole architecture in few seconds. So integration is also some sort of a, like you can say in the positive side. So I think this is some sort of like I will skip for this one. Uh, I'll skip for this. Now, coming to this, the future of the containerization is in the coming world. You are also already seeing the growth. The growth is very vast. Coming to this, microservices. Companies are right now moving towards this microservices. Microservices all based on this containerization, where different architecture is completely based on this containerization tools, and each of these containers are placed in such a way that whole architecture is so portable, so scalable that you can easily take this particular architecture within few seconds, a few minutes to a different whole new different platform. Okay, this is particular thing you can say it's a power of coding, or you can say the power of this you can say Docker containers, that you can move your whole architecture within few seconds to a different new next level, or you can also scale up scale down at the same time. Okay, now experts and jobs are already there in the market. If I'm working like 3 years, so if I will tell you, most of the companies are looking for the Kubernetes engineers. So one of the certification is there for this certified Kubernetes architect, and CKAD developer is also there, certified Kubernetes developer. So these are the two certificates for this. For Docker containers, yes, there are also demands, but for not exactly the Docker containers, there's second level of thing which you were saying, which I was telling you about, Kubernetes orchestration tools. So orchestration is all about managing the whole container part. Okay, whole deployment part, whole architecture part. So Kubernetes is used over there. So for this, companies are looking for service. This whole thing which I was telling you about, service mesh and all this. This is all coming out of this only. So Kubernetes containers, Kubernetes engineers, all of these are going to have this particular opportunities in the this microservices environment. So guys, that's all from my side for this. Just quickly take few minutes of yours to just tell you if I can bring this particular Fedora image up or not. I don't know, guys, what something is happening with my system today. Uh, okay.
No worry at all, Ayush. No worry at all. Sometimes things
Yeah.
happen. We are living in a digital era, so there is no
Uh,
issue at all.
no, I don't know. Like something is happening with my system today. Like I just checked it few minutes ago, and I brought
Okay.
that up, but I don't know like what got into this. We'll
That's
try
why they
it
are
next
called
week.
as that's why they are called as electronic devices. Sometimes so things are not working as we expected. So there is no
Yeah.
worry at all. You can drop that whatever the command or whatever the result that you want to show in the in
Yeah,
our community,
I will
so
be
that we
dropping
can
in my
post it.
chat box.
Yeah.
Okay. So download command, you can check the whole process of downloading of this particular Docker container you can use. So let me just share you the link.
I guess that would be great.
Yeah. So yeah, this is one of the thing you can use for Docker CLI and all. Okay. So this is the command which was trying out for this one, and for installing, I'm also sharing some sort of link.
Okay. Mother, please drop these two links on YouTube chat section, if possible.
So yeah, I'm so sorry, guys. I wanted to show you
No
something
issue at
crazy
all.
out.
No worry at
So
all.
there is some sort of like if you will check out, check on the YouTube as well, on the documentation as well. So you will be able to find a particular container run in few seconds and within a particular single process. This is the what I wanted to show you today. So this is the power of containerization right now. Yeah.
That's great.
Thank you, guys.
So, yeah. Thank you, Ayush. Thank you for sharing your valuable experience and your insights on the Docker concept. I must say, it will inspire and help many students who are watching us right now. So, any piece of advice or any single piece of suggestion from your end who are learning
So
this Docker?
if you wanted to learn this particular Docker, so there is some sort of a like playlist on you can say IIEC Connect is one of the channel on the YouTube.
Okay.
which I will refer people to use. Some other channels are also there, which I will share with the Madhur afterwards.
Okay.
We can share in the chat sections. Okay. So these are some sort of a channels you can use. But coming to this, see, whichever person is going towards the side of automation, whichever person is going towards the side of Docker, this containerization, microservices, this is the first step for him to learn this particular thing. Okay. Also with this, I will suggest learning Linux, which
Okay.
will help you understand the networking part and another things for managing the Docker networking and all those things. So yep, that's all.
Okay, that's great. And thank you once again for accepting our invitation and sharing your learnings with your all juniors and all the audience who are watching us right now. So yeah, so okay, Mother, we can wrap up this session. And once again, on the behalf of all the engineers, thank you, Ayush. Thank you for
Yeah.
taking this session. Yeah. So bye,
Thanks for
guys.
calling me
We'll
up. Yeah.
yeah,
Thanks to
it's our
Engineer
pleasure.
Doctor.
Thank you.